Greetings, it's Max ODidily here, and today I am going to be showing you how to decrypt an encrypted message using Caesar Cipher. So if you haven't watched the how to encrypt data using Caesar Cipher tutorial, click the eye up in the corner. And by the way, this is going to be for C#. So let's get right into it. So in our main method, we have got obviously what we had in the last tutorial. We've encrypted the message and we've printed it out. But here we've got two extra lines of code. We're going to do string decrypt text equals decrypt, ciphertext and shift. I'll explain what shift does in a moment and what ciphertext is, but this is going to be getting our decrypted message, which we've called descrypted message for some reason. And then we do console.writeLine, descrypted text, and console.read to stop the console from closing. So we're going to take this encrypted message, decrypt it, and print it out to the screen. So let's define our decrypt function. We are going to do static string decrypt, string ciphertext, and int shift. So how does Caesar Cipher work? Well, basically, we get a letter and we have a shift, and we want to shift each letter by a certain amount of letters through the alphabet. For example, if I have the letter A and a shift of 3, that A becomes a D because it's been shifted 3 characters. So how do you think we decrypt it? Well, we get that shift and then we do the opposite. So that D gets shifted 3 letters up the alphabet back to A. And that's what we're going to be doing. So in our decrypt function, we're going to do string plain text equals nothing. This is going to be our decrypted string. And then we do for each char C in ciphertext. We're going to be looping through every character in this encrypted message. And then after we do a return plain text to return the decrypted message to where we call the function. Inside we've got a bit of code, but don't worry, we're going to break it down. We do if char is letter C. We're going to be checking if the current character we're looking at is a letter. So in this encryption, we're only going to be encrypting letters, and those letters are all converted to lowercase. So any uppercase letters become lowercase, then get encrypted, to keep it simple. So we do char lower c equals char.to lower c. Then we do char shifted equals char lower c minus shift minus a plus 26 mod 26 plus a. And then we do plain text plus equals shifted. And in the else statement we do plain text plus equals c, because if it's not a letter, we don't apply any encryption to it. Now, let's explain what this line of code does. Well, it does the opposite of what it did in the last tutorial, so yeah. But here's an explanation anyway. So this code is used to shift a lowercase letter in the English alphabet by a specific number of positions in the opposite direction using Caesar Cipher. It's opposite because we're decrypting. The lower c variable is a lowercase letter that is being shifted, and the shift variable is the number of positions that the letter should be shifted in the opposite direction in the alphabet. The first code subtracts the ASCII value of shift from the ASCII value of lower c. This moves the letter shift positions to the left in the alphabet. The result of this subtraction is then adjusted by subtracting the ASCII value of the letter A, adding 26 and taking the mod of 26 to ensure the result is always within the range of the English alphabet. Basically, let's say we go beyond the letter A, then we loop back around to the letter Z and carry on. Finally, the result is added back to the ASCII value of the letter A to obtain the final shifted letter. This shifted letter is cast to the char data type and assigned to the shifted variable. And that's basically what it does. With all of that, we are going to save our work and hit play. As you can see, we've got our encrypted message. Core Zrog 123 DDD. And then we do hello exclamation mark world 123 AAA. So if you look at the original message, there were some uppercase letters, and these obviously got converted to lowercase when encrypted, so when we decrypt it, we don't get those cases back. It's more complicated to include casing, numbers, and special characters, so I've excluded that from this tutorial, but those can be encrypted with more advanced algorithms. But anyway, thanks for being a great audience, be sure to leave a like and a comment if you enjoyed, and subscribe for more C# tutorials. Thanks for watching!